Right, looking at quiz 1, first quiz in unit 1 this September. This is the key. So taking a look at the video here. So it says, the first question here says, circle the molecule with the largest dipole moment and use 3D drawings to explain your answer. So in this case, 3D drawings is the wedges and hatches, hopefully, using these arrows to indicate, right, this is delta plus and towards electronegativity, right? So in this case, you have 3 chlorines and 1 H. This itself creates a dipole moment for electron density pointed this way. Whereas when there's 4 chlorines, they equally pull away, so there's no actual dipole moment. Nice 3D drawings, showing right, electron density going the other way. Next question was, draw the Lewis dot structure for HPO3. Show your work, include all lone pairs, indicate the formal charges of all atoms. 4 points. And then the big hint here was all atoms will obey the octet rule. That should help you think, wait, so the phosphorus here is not going to act like sulfur does and expand its octet. Everybody's going to obey the octet rule. So phosphorus is right below nitrogen, so this would behave very similar to what a nitrogen would. So you can imagine nitrogen wants to have 3 bonds, phosphorus also wants to have 3 bonds, has 5 valence electrons. So it's bonded, it has 4 bonds, so the phosphorus is going to have a plus charge, the O would have a minus charge, and then the other OH is over here. Big thing people try to do, if there's no charge here, the overall charge of the molecule, there can't be an overall charge of the molecule, right? So minus and plus is neutral, and a lot of people should have recognized, wait, if there's no charge here, I can't in the end have a charged molecule. So really got to take a look at that. Make sure before you think you're done, make sure there's no charge there. But again, the big hint, obey the octet rule. Obey the octet rule in this case. Why does size increase as you go down a period in the periodic table? Right? Simply put, more electrons, more orbitals, taking up more space, right? As you go from fluorine to, say, iodine, just getting bigger, going to be more electrons, more orbitals, just going to become a bigger element, bigger atom. Assign the hybridization state of the indicated atoms in the compound below. Again, taking a look at this nitrogen right here, you always ask yourself, how many pi bonds do I have? It has 1 pi bond. That means it, of course, is sp2 hybridized. Box those in. This carbon right there, it's sp hybridized, it has 2 pi bonds. It has 2 pi bonds, so it's sp hybridized. And this nitrogen right here doesn't have any pi bonds, so then it's sp3 hybridized. Drawing the orbitals in, again, it's just kind of the same idea. We box in our hybrid orbital states, our hybrid states, draw the orbitals associated with that hybrid state. sp3, you need 4 bonds, all similar. So it's 4 sp3 orbitals, shaped like that. Be careful with the shapes. sp2 has a p and 3 sp2s, because for a pi bond, make sure you draw your p orbitals different than your sp2 or any of the other ones. Make sure they're indicated that there's p. Notice the shading indicating the phases, the electron waves. sp, 2 pi bonds, that means you need 2 p orbitals. What's left over, 2 sp orbitals to form those last 2 sigma bonds. Page 2 here, it says define the acid and base on each side of the reaction below. So again, remembering that acids are electron deficient, bases are electron rich. If this is electron rich, because it's a negative charge, that's a base. The other thing must be an acid. Then the other side, or the conjugate side, again, sulfur has a negative charge, that's a base. Whatever is delta plus or electron deficient, that would be an acid. So there you go. Draw the lone pairs in. This oxygen has 3 lone pairs, or has 1 bond, has a negative charge. I mean, it has 3 lone pairs to fulfill its octet, right? 2 from the bond, 2 from a lone pair, 2 from a lone pair, and 2 from a lone pair for 8. Sulfur, just like oxygen right below it, should have 2 lone pairs. Oxygen should have 2 lone pairs. Then now here's sulfur, should have 3 because it got a lone pair and this SH bond broke, so there's 3 there. Correct mechanisms. Arrows, again, where do electron arrows start? They always start at electron density. So that's where your arrow should start, going towards electron deficiency and showing these 2 electrons from that SH bond going to the sulfur and ending up there. So in this one, draw the structure of the expected conjugate base and acid in the following reaction. And a couple parts to it. Did you understand what pKa meant? pKa, right, the lower the pKa, the more reactive this OH bond would be. So this is the actual acid in this case, and this would be the base. So the conjugate base would have a negative charge here. The conjugate acid with a plus charge there. I didn't draw lone pairs in here, so this is the base, that's the acid. Another couple things we saw, people weren't putting charges in, right? No net charge over here. Make sure you have no net charge over here. You can have a minus and a plus, but they have to cancel each other out. Another question is why is the pKa lower for the first molecule? If you look at the product can do resonance, right? It can spread its charge out and put a negative charge spread out from the oxygen to the carbon. So it spreads its charge out more, makes for a more stable product. Bonus question talks about, so below is the DNA base pairs thymine and adenine. Their interaction is an example of hydrogen bonding. If the circled nitrogen right there was replaced with an oxygen, this interaction would disintegrate, and life as we know it not exist. Why? So basically we're trying to get at what's the difference between oxygen and nitrogen, right? The big difference is oxygen or nitrogen is less electronegative than oxygen. Therefore, it's more willing to hydrogen bond with this lone pair, right? So remember this, there's a lone pair in this nitrogen that's helping do this hydrogen bond interaction. If that was an oxygen is more electronegative, so it holds its lone pairs tighter. You wouldn't want to do this interaction. Also, if you're just practically thinking about it, if you put an oxygen there, that oxygen would have 3 bonds, and then it would have a plus charge, and only 1 lone pair, and it'd be really unlikely for it to ever want to share those lone pairs if it already has 3 bonds and has a plus charge.